right, and we are back. So let's go ahead and look at assigning variables versus asking for equality. So what we mean by this, and we've already actually defined variables previously, is we're going to see when we have to use the single equal sign versus using the double equal sign. So if I want to assign a equals 7, let's go ahead and shift evaluate that, and then a times 5. So that'll give us our values. So this gives us, that's assigning a variable. So we're assigning a value permanently until we clear the function. We're assigning a value to this variable. That is different from asking for equality. So for example, are we saying, does 8, the double equal sign is asking, does 8, or we're, basically, well, it is asking for double, is 8, but we'll use this in solve a lot as well. Does 8 equal to A? And that's true. Is 8 equal to 7? False. So we're going to set up equations, and whenever you use solve and some of these values, you're going to use the double equal sign. So again, it's imperative upon you that you look, and actually I'm going to type here, asking, are they equal with double equal sign, useful syntax using solve. So solve is one where you have to really use double equal sign. So when you're using equal or double equal, you have to kind of read and look at the syntax in your equations as well. All right, so creating functions in Mathematic and using also, not only using creating functions, but looking at equations and kind of solving values as well. So we can also assign values, not only assign values to a variable, but we could kind of create a function effectively. So let's do a couple functions equals log of x times cosine, or actually let's do arctan of x, and then I could also do c is equal to a squared plus b plus square root of b. And now I could start to look and play with these functions and also kind of start to do mathematical operations on them. So I can take the derivative of my function a with respect to a variable x. So again, that syntax, so let's go ahead and type it out. D is derivative function. So remember, if I type in D here, D is already black. It's pre-assigned. If I try to assign it a number, I get this error. Symbol D is protected. So in Mathematica, this is already a function. So I could go ahead and look that up in my help menu, and I could type in D, and then I could read what's the syntax of this equation. So I could do the partial derivative, I could do the second derivative, the third derivative, the fourth derivative. You got lots of options here. And again, read through, look at these examples, look at it's always fun to kind of look at neat examples. This is a really nice one. You're looking at the tangent vector to this function. Really kind of fun things that you can do in Mathematica. So be diligent in terms of reading about the function, and again, you have to start to be comfortable and learn with the syntax of the equation. So having this help menu open and then also your notebook open at the same time is going to be very helpful. So D is derivative with respect to x in this equation. I could also take the second derivative of a. I could do the third derivative, the fourth derivative, etc., 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 etc. So you could do those as well. I could also integrate a function. So I could integrate with respect to x. I could also integrate my function c with respect to x. Oh, that's going to give me, so very complicated. I can also numerically integrate c with respect to x from, let's do x. Actually, let me see if I can remember the syntax from 1 to 5. Let's go ahead. And I could get a numerical integration. So that's what we're kind of working with here, and that's going to be kind of how we're going to be using this. So you will use this a lot, especially if you're dealing with relatively simple functions with one or more variable, and you're just trying to perform mathematical operations. This is a nice way to kind of create functions in Mathematica. We'll look at a more elegant way a little bit later today, but this is the kind of your workhorse, effectively. Now, MATLAB is the master of numerical calculations, but we are going to be doing a lot of linear algebra, ODE solving. We're going to be solving lots of equations simultaneously, but we're also going to be working with large data sets as well. And what this necessitates is the ability to work with lists and matrices and tensors as well. So we're going to see how Mathematica works with these values and how can we basically work with these types of lists. So I'm going to create a random list. It's going to be random. Use a function. It's called random integer. It's going to select from -10 to 10, so those are the bounds. And then it's going to give me 10 values here. So again, random integer from -10 to 10, and then gives me 10 values. So I've got my random list, so I could start to look and visualize this list. So I could do our list table form. So you could see here for a list, I have one row and I've got 10 columns here. So I could start to look at the dimensions of my list. So that's the dimension. So I have 10 basically rows in my list. I could do the length of my list, very, very similar as well. I could also create matrices. So random matrix, I'm gonna do a 3x3 because that's gonna be, 3x3 matrices are very important because once we get to kind of linear algebra, we're going to be working a lot and applying linear algebra concepts to solid mechanics, which has to deal with tensors, and since we live in a 3D world, 3x3 matrices are going to be very common. So I could visualize matrices using matrix form. I could also do matrix form on my list as well. Let's do our list. So I can visualize that as well. Be careful with matrix form. If I set this as a variable, so let's just call this a var. If I set this as a variable, I cannot do, and I want to multiply this by 5, it won't allow me to do mathematical operations as opposed to this. So just be cautious of that. I could also make a 2x3 matrix. So matrix 2, 2. Let's go here, 4, 5, and let's go here. 7, 8. Let's go our matrix. So our matrix 2, and again, I can look at that matrix form as well. So again, when I look at the dimensions, it's very important when you're importing data, you kind of have to see what style of data you're importing, kind of what are you working with, and dimensions and length are very important. So I could do our matrix 3x3, dimensions of our matrix 2. I could do length of our matrix, and that's going to give me, again, these are, again, rows. So let's kind of type it out. Rows first, and then columns. So that's kind of the way those go. Excellent. So I can now start to play and do mathematical operations on this list. So I could do our list -1. I could do our list times 10. I could do our list squared. I could do square root our list. I could do cosine of our list. I can start to do really kind of fun things, in mathematical operations on the list. Now, often you're not going to be kind of so lucky in terms of how you can, accomplish this. But anyways, and actually we'll look at different functions. We'll actually loop with table functions as well in order to kind of work with these values. But one of the most important things when you're working with lists is grabbing and extracting elements of that list. So for example, if I want to grab the first element of a list, all I have to do is this, double square bracket 1. So this gives me first element in list. So excellent. I could also grab the first 5 elements. Our list 1, semicolon, semicolon, 5. I can ask to give me the second to the last element. Like here, again. So that will give me the second to the last element here. I could ask, give me our list from -7 to -3. I could grab that. Again, lots and lots of values that you can kind of play around with this. So I could also ask, what's the max? What's the maximum value? what's the minimum value in my R list? What's the mean of my R list? What's the standard deviation of my R list? Again, you can start to do and play around with lots and lots and lots and lots of different values. You could also sort your R list by greater values. I could sort my R list by fewer. Actually, or less. I could round my R list to the nearest 100. And then you see they all go to 0. So lots and lots and lots of different values. I could even sort, or actually I could select from my R list the even cube. I can select R list odd. Let's see if there's an odd cube. I can select again, lots of fun functions. I could select the prime values of RQ. So these are very useful functions here, especially the extraction function. The extraction functions are very, very, very important. I can also find positions in my R list. So for example, I could look and ask in my R list, what is the position of the 5th value? Or where do I find 5? If there's multiple values, for example, let's do -2, it'll show multiple values where that occurs in the list. So you can pull out those functions and then see where you're going in the list. Excellent. So that's a lot of list manipulation, extraction, creating variables, equalities. So next time we're going to get into rules and replacements, and the most important function in Mathematica, table function. So thanks, and I'll see you all next time. All right. Have a good one. Bye.